Here is a time and longitude calculation pulled directly from a DGCA exam paper. UTC is 0800, and the aircraft is at 90 degrees east. Find the local mean time. Most students freeze when they see this, or they try to remember complex conversion tables. But you can solve this in your head in under 15 seconds. Every single time and longitude problem in aviation comes back to exactly one physical truth about the Earth's rotation. Once you master this single framework, you eliminate the need for complex conversion tables, allowing you to approach these questions on the Paper 1 exam with much higher confidence. The Earth completes a standard 360-degree rotation every 24 hours. That physical movement is what drives all timekeeping. Earth rotates 15 degrees every hour, meaning 1 degree equals exactly 4 minutes. To calculate arc to time, multiply your degrees by 4. 90 degrees times 4 is 360 minutes, or 6 hours. Reversing this, 180 minutes divided by 4 is 45 degrees. Because the physical rotation of the planet is a constant, these calculations provide a consistent framework that holds up regardless of the aircraft's position or the complexity of the flight plan. Next, we establish our 3 time standards. First is Coordinated Universal Time, or UTC. This is the absolute 0 point and the mandatory world standard for all aviation. Second is Local Mean Time, or LMT. This represents the actual solar time at a specific longitude. Third is Indian Standard Time, or IST. This is a regional fixed standard based specifically on the 82.5 degree east meridian. It is explicitly calculated as UTC plus 5 hours and 30 minutes. This timeline maps the directional rule. East is ahead, west is behind. 60 degrees east is 4 hours. East means add. UTC 10 a.m. becomes LMT 1400 a.m. 60 degrees west is 4 hours behind. Subtract from UTC 10 a.m. for LMT 06 a.m. Committing this simple mnemonic, east is ahead, west is behind, to memory helps prevent the directional hours that commonly occur in navigation exams. Stop. Let's test this directly. UTC is 0630. The aircraft is at 45 degrees west. What is the local mean time? Pause the video right now, use the formulas we've covered, and work through the mental math before you proceed. Step 1. Multiply 45 degrees by 4 to get 180 minutes, which converts to 3 hours. Step 2. West means subtract. 0630 minus 3 hours arrives at 0330 LMT. We can now shift our geographical context to the Pacific Ocean to introduce the final variable, the 180-degree meridian, formerly known as the International Dateline. This map illustrates the westbound rule. Crossing east to west, you lose time on the clock, pushing the calendar date forward 1 day. Conversely, crossing west to east, you gain time, forcing you to subtract 1 day from the calendar. While standard longitude affects your hours and minutes, the dateline is the only meridian that manipulates the overarching calendar date itself. Now, let's return to the numerical problem from the opening of this video. UTC 0800 at 90 degrees east. Apply the core physical formula. 90 times 4 is 360 minutes, or 6 hours. East means we add. 0800 plus 6 hours gives us a definitive answer of 1400 LMT. Here are your absolute rules. 15 degrees per hour, 1 degree per 4 minutes, east add, west subtract, and IST equals UTC plus 530. Using these physical constants allows you to verify your answers logically, which is more dependable than relying on rote memorization under intense exam pressure. For our next navigational challenge, we'll examine inertial navigation systems to see exactly how modern aircraft navigate completely blind using 0 ground stations and 0 GPS signals. Subscribe so you don't miss it.